Children, when I said in this particular chapter loci, that loci chapter is mixed with construction nowadays. So what are the few kind of sums which can come in boards and which have already appeared in board? Let's see. What I'm going to do is I'm going to make you understand the entire solution. My diagram will be not that exact, it's going to be a rough one. I shall give you the solution also in a neat way in my solution box. So let's understand how loci is related with construction. Now before you proceed with these sums on loci, I would request you all first to visit construction. Understand every single sums of basic construction, how to go for construction of circumcircle for triangle, incircle for triangle, circumcircle and incircle for hexagon, right? How to go for tangents. It's only after you finish off doing construction sums. It's only after doing your construction sums, then and then only you'll proceed with sums based on loci, not before that. Right? I advise you to do construction first, then loci. Right? Let's see what is this one trying to say. It says construct triangle ABC. It says construct triangle ABC in which base BC is 5.5, AB is 6 centimeter, angle ABC 120 degree. So let's first construct the triangle. They have already told us that base should be BC. Okay, so we are going for making base BC. How much? 5.5 centimeter. What next? AB is 6 centimeter. Okay, AB is 6 centimeter. But angle ABC is 120 degree. An angle 60, 120. You go for it. Is this 120, children? Indeed, yes. With B as a center, 6 in my compass, I go for an arc. This is A. B as a center, 6 in my compass, draw an arc. This is 6 centimeter. Draw a triangle ABC. At least we are done with the first part of the sum. Draw triangle ABC. What next? Construct a circle circumscribing triangle ABC. So this first part is from construction. Second part belongs to loci. So you'll understand the picture, what I was saying. Sir kept on saying that loci and construction nowadays are being compiled together. So they say draw a circumscribing circle. So in order to go for circumcircle, we should go for perpendicular bisectors of any two sides. Right? We should go for perpendicular bisectors of any two sides. I'm just right now drawing in a very free way, and this is perpendicular bisector of one side, this is perpendicular bisector of other side. They will intersect at point. This is very rough, children. This is very rough. They will intersect somewhere outside. This is my point of intersection, and this is how my circumcircle of triangle ABC is going to look like. I know it's a bit abnormal figure, but yes, this is how circumcircle of triangle ABC is going to look like. So I'm done with my first part. They further say draw a cyclic quadrilateral. So by this time you know, you must have done circle. What's a cyclic quadrilateral? A quadrilateral whose all the four vertices lie on the circumference of the circle. A quadrilateral whose all the four vertices lie on the circumference of the circle is termed as cyclic quadrilateral. Draw a cyclic quadrilateral ABCD so that D is equidistant from B and C. So kindly understand this part. Equidistant from B and C. When they say equidistant from B and C, come on, focus on your theorems which I said. Equidistant from B and C, it should lie on the perpendicular bisector of BC. So what next we are supposed to go for? We are supposed to go for perpendicular bisector of BC, B and C. Now what happens over here, that when I was trying to draw a circumcircle, my perpendicular bisector got already made from our side. So if I were to say that D is equidistant from B and C, so I would have gone for a perpendicular bisector of BC. Every point lying on this perpendicular bisector, let me jot down, this is a perpendicular bisector, mind you. Had I not taken perpendicular bisector of BC while drawing circumcircle, and had I taken perpendicular bisector of AC, then now in order to satisfy this second condition, I have to draw perpendicular bisector of BC. Why? D is equidistant from B and C. So when a particular point is equidistant from dash and dash, it lies on the perpendicular bisector. So how many points do I have on this perpendicular bisector? N number, infinite. So all that infinite points can be termed as point D. But there is a condition to satisfy. I have to have a cyclic quadrilateral. So for that, the fourth point should be on the circumference. So in spite of n number of points which are lying on this perpendicular bisector, my point shall be only one point D. Why? Because the D has to be on the circumference of the circle. Question arises, sir, even point D could have been here also. So let me show you with a different marker. Even that point D could have been here also. D dash, if this were to be D. If this were to be D. Agreed, children. If you are thinking in that direction, you all are not wrong. You all are absolutely right. Because there are infinite number of points, but there are 2 points which lie on the circumference of the circle. One is here, one is here. One more thing, they want cyclic quadrilateral A, B, C, D. So I shall take this, and I'm not going to take D dash. I'll give you an answer for that. So A, B, C, and I'm going to complete this C to D, A to D. My cyclic quadrilateral A, B, C, D is ready, which satisfies both the condition. Now the question arises, why not this point, sir? What type of quadrilateral it would have been? A, B, D, C. Had I gone for that D, the quadrilateral would have been A, B, D, C. And that's the reason we opted out for this point D. And now did you get it? Why sir kept on saying that loci and construction are nowadays coming in one single sum? So first part was from pure construction, second part from pure loci combined together. These kind of sums is what nowadays board asks.